Hello students, welcome to my YouTube channel. Today I am going to discuss relaxation method for the solution of equations. Relaxation method is one of the methods for the successive approximations of the roots of algebraic linear equations. It gives a solution for all unknowns simultaneously. For the illustration of the method, we consider a set of three linear equations in three unknowns. Let us consider the equations a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. Here, diagonal coefficients are dominants. Let us define residuals Rx, Ry, Rz by the following relations. Rx equal to d1 minus a1x minus b1y minus c1z. Ry equal to d2 minus a2x minus b2y minus c2z. Rz equal to d3 minus a3x minus b3y minus c3z. If we become able to find the values of x, y, z so that Rx equal to Ry equal to Rz equal to 0, then these values of x, y, z are the exact values of the unknowns of the system. The required solution consists of the set of x, y, z for which residuals are 0 or very near to 0. To start with, we assume x equal to y equal to z equal to 0 and calculate the initial residuals. Clearly, when x equal to 0, y equal to 0, z equal to 0, then Rx equal to d1, Ry equal to d2, and Rz equal to d3. Then the residuals are reduced step by step by giving some increments to the variables. When x is increased by 1, keeping y and z constant, then Rx becomes R dash x equal to d1 minus a1 into x plus 1 minus b1y minus c1z equal to d1 minus a1x minus b1y minus c1z minus a1 equal to Rx minus a1, since Rx was d1 minus a1x minus b1y minus c1z. That is, Rx is decreased by a1. Similarly, Ry is decreased by a2 and R dash is decreased by a3. Thus, if x is increased by 1, then we write delta x equal to 1, Rx, Ry and Rz decrease by a1, a2, a3 respectively. Similarly, we find effects on the residuals when delta y equal to 1 and delta z equal to 1. These effects on the residuals can be shown by the following table. First column increments, second column delta Rx, third column delta Ry, and fourth column delta Rz. When delta x equal to 1, delta Rx minus a1, delta Ry minus a2, delta Rz minus a3. delta y equal to 1, delta rx minus b1, delta ry minus b2, delta rz minus b3. And when delta z equal to 1, delta rx minus c1, delta ry minus c2, delta rz minus c3. At each step, the numerically largest residual is reduced almost to zero. In reducing a particular residual, the value of the corresponding variable is changed. In case when all the residuals have been reduced to almost zero, the increments in x, y, and z are added separately to obtain the desired solution. Now, the method is given by the following example. That means we are going to solve a problem by relaxation method. The problem is solve the following equations by relaxation method. Equations are 9x minus 2y plus z equal to 50, x plus 5y minus 3z equal to 18, minus 2x plus 2y plus 7z equal to 19. Solution. Since the diagonal elements of the system of equations are dominant, and so relaxation method can be used for the solution for the above system of equations. The residuals are given by Rx equal to 50 minus 9x plus 2y minus z, Ry equal to 18 minus x minus 5y plus 3z, and Rz equal to 19 plus 2x minus 2y minus 7z. We now compute the following operation table. First column, variables, increments. Second column, residual component increment delta Rx. Third column, residual increment delta Ry, and fourth column, residual increment delta Rz. Increments when delta x equal to 1, delta Rx minus 9, delta Ry minus 1, delta Rz 2. When delta y equal to 1, delta Rx 2, delta Ry minus 5, delta Rz minus 2. When delta z equal to 1, delta Rx minus 1, delta Ry 3, delta Rz minus 7. Now we form the relaxation table. First column serial number, second column variables, third column Rx, fourth column Ry, and fifth column Rz. Serial number 1, x equal to y equal to z equal to 0, Rx equal to 50, Ry 18, Rz 19. Second, serial number second, we see here that 50 is the largest. So we have to reduce 50 to almost 0. So we want to take delta x equal to 5, so that in above table for Rx was minus 9. So Rx will become 50 minus 9 into 5, that is equal to 5. Correspondingly, 18 minus 1 into 5 equal to 13. Rz 19 plus 2 into 5 equal to 29. Now, the residual 29 of Rz is the greatest, so we have to reduce this residual 29. Now we go to the above table in RZ, where the number is minus 7. So if we take delta Z equal to 4, then RZ will become 29 minus 7 into 4, that is equal to 1. Serial number 4, we take delta Y equal to 5 to reduce the residual R by 25, which is the largest, and correspondingly Rx will 1 plus 2 into 5 equal to 11. Ry 25 minus 5 into 5, that is 0, and Rz 1 minus 2 into 5, that is minus 9. Now the residual Rx is the greatest, so we have to reduce this residual Rx equal to 11. So we take delta x equal to 1, and then Rx will become 11 minus 9 into 1 equal to 2. Ry 0 minus 1 into 1 equal to minus 1. Rz minus 9 plus 2 into 1 equal to minus 7. Now residual Rz minus 7 is the greatest in magnitude. So we have to reduce minus 7. So we take delta Z equal to minus 1. So that Rz becomes minus 7 into minus 1, that is 0. Correspondingly, Rx becomes 2 minus 1 into minus 1 equal to 3, and Ry become minus 1 plus 3 into minus 1, that is equal to minus 4. Now minus 4 is greatest, which is Ry. So we have to reduce Ry. So we take delta y equal to minus 0.8. And then Ry becomes minus 4 minus 5 into minus 0.8 equal to 0. Correspondingly, Rx becomes 3 plus 2 into minus 0.8 equal to 1.4, and Rz becomes 0 minus 2 into minus 0.8, that is equal to 1.6. Now the residual Rz is 1.6, which is the greatest residual. So we take delta Z equal to 0.23, and then Rz becomes 1.6 minus 7 into 0.23, that is equal to minus 0.01. Correspondingly, Rx becomes 1.4 minus 1 into 0.23 equal to 1.17, and Ry becomes 0 plus 3 into 0.23 equal to 0.69. Now Rx 1.17 is the greatest residual, so we take delta x equal to 0.13 to reduce, and then Rx becomes 1.17 minus 9 into 0.13 equal to 0. Correspondingly, Ry becomes 0.69 minus 1 into 0.13, that is equal to 0.56, and Rz becomes minus 0.01 plus 2 into 0.13 equal to 0.25. Now residual Ry 0.56 is the greatest, so we take delta y equal to 0.112, and then Ry becomes 0.56 minus 5 into 0.112 equal to 0. Correspondingly, Rx becomes 0 plus 2 into 0.112 equal to 0.224, and Rz becomes 0.25 minus 2 into 0.112. Now we see that residuals Rx, Ry, Rz are very small numbers. So we can add the values of delta x, delta y, and delta z. Thus residuals are very near to 0. So here sigma delta x equal to 5 plus 1 plus 0.13 equal to 6.13. Sigma delta y equal to 5 minus 0.8 plus 0.112 equal to 4.312, and sigma delta z equal to 4 minus 1 plus 0.23 equal to 3.23. Hence the solutions are x equal to 6.13, y equal to 4.312, and z equal to 3.23. Thus, the equations have been solved by relaxation method. Now, we take another example. The problem is solved by relaxation method. Equations are 10x minus 2y minus 3z equal to 205, minus 2x plus 10y minus 2z equal to 154, minus 2x minus y plus 10z equal to 120. The given equations are 10x minus 2y minus 3z equal to 205, minus 2x plus 10y minus 2z equal to 154, minus 2x minus y plus 10z equal to 120. The residuals are given by Rs equal to 205 minus 10x plus 2y plus 3z, Ry equal to 154 plus 2x minus 10y plus 2z, and Rz equal to 120 plus 2x plus y minus 10z. We now compute the following operation table, means coefficients of x, y, and z. First column increments, and second, third, fourth columns are residuals. Second column delta Rx, third column delta Ry, fourth column delta Rz. When delta x equal to 1, delta Rx minus 10, delta Ry plus 2, delta Rz 2. When delta y equal to 1, delta Rx 2, delta Ry minus 10, delta Rz 1. Delta x equal to 1, then delta Rx equal to 3, delta Ry equal to 2, delta Rz equal to minus 10. This is operation table. Now we form relaxation table. In this table, first column serial number, second column variable and increments, third column Rx, fourth column the residual Ry, and fifth column residual Rz. Serial number 1, when x equal to y equal to z equal to 0, residuals Rx, Ry, Rz are 205, 154 and 120 respectively. Here we see the residual of Rx is 205, the greatest residual. So we have to decrease 205 to very low number, very near to 0. So we take delta x equal to 20, since in Rx column of operation table, there is minus 10. So, when delta x equal to 20, Rx becomes 205 minus 10 into 20, that is equal to 5. Correspondingly, Ry becomes 154 plus 2 into 20 equal to 194, and Rz becomes 120 plus 2 into 20, that is 160. Now, Ry becomes 194, which is the greatest. So, we have to decrease Ry. So, we take delta y equal to 19, and then Ry becomes 194 minus 10 into 19, that is equal to 4. Correspondingly, Rx becomes 5 plus 2 into 19, that is 43, and Rz becomes 160 plus 1 into 19 equal to 179. Now, Rz becomes 179, which is the greatest. So, we have to find a number so that 179 can be decreased. So, we take delta z equal to 18. And then Rz becomes 179 minus 10 into 18, that is minus 1. Correspondingly, Rx becomes 43 plus 3 into 18, that is 97. And Ry becomes 4 plus 2 into 18, that is 40. Now, 97 is value of Rx, which is the greatest. So, we have to diminish 97. So, we take delta x equal to 10. And then Rx becomes 97 minus 10 into 10, that is equal to minus 3. Correspondingly, Ry becomes 40 plus 2 into 10, that is 60. And Rz becomes minus 1 plus 2 into 10, that is 19. Now, Ry is 60, which is the greatest. So, if we take delta y equal to 6, so that Ry becomes 60 minus 10 into 6, that is 0. Correspondingly, Rx becomes minus 3 plus 2 into 6 equal to 9, and Rz becomes 19 plus 1 into 6, that is 25. Now, Rz equal to 25 is the greatest number, greatest residual. So, we take delta z equal to 2, and then Rz becomes 25 minus 10 into 2 equal to 5. Correspondingly, Rx becomes 9 plus 3 into 2 equal to 15, and Ry becomes 0 plus 2 into 2 equal to 4. Now, Rx equal to 15 is the greatest residual. So, we take delta x equal to 2, and then Rx becomes 15 minus 10 into 2, that is minus 5. Ry becomes 4 plus 2 into 2, that is 8. And Rz becomes 5 plus 2 into 2 equal to 9. Now, Rz residual is the greatest, that is 9. So, we take delta z equal to 1, and then Rz becomes 9 minus 10 into 1 equal to minus 1. Correspondingly, Rx becomes minus 5 plus 3 into 1 equal to minus 2, and Ry becomes 8 plus 2 into 1 equal to 10. Now, the residual Ry equal to 10, which is the greatest. So, we take delta y equal to 1 to reduce this number, and Ry becomes 10 minus 10 into 1, that is equal to 0. Correspondingly, Rx becomes minus 2 plus 2 into 1 equal to 0, and Rz becomes minus 1 plus 1 into 1 equal to 0. And thus we see that residuals Rx, Ry, Rz all become 0. So, we shall add values of delta x, delta y, and delta z to find the solution. Now, Here sigma delta x equal to 20 plus 10 plus 2, that is equal to 32. Sigma delta y equal to 19 plus 6 plus 1 equal to 26. And sigma delta z equal to 18 plus 2 plus 1 equal to 21. Hence, the solution will be x equal to 32, y equal to 26, z equal to 21. Thus, we have solved the system of equations by relaxation method. Thank you. Hello students, we shall discuss more topics and important topics, important theorems and problems of degree part 3rd and other courses. So please subscribe my channel. Thank you.